Welcome to Facts with AI. Today we're diving into some of the weirdest facts about life on Mars. Buckle up because this is going to be an out-of-this-world journey. Mars, the red planet, named for its rusty hue, has captivated humanity for millennia. Long before telescopes, even before the invention of the written word, our ancestors looked up at that wandering red star, imbued it with gods and monsters, and wondered, is there somebody out there? Today, we stand on the precipice of an entirely new understanding of Mars. No longer the realm of myth and speculation, we now have rovers traversing its surface, their cameras beaming back images of a world both eerily familiar and shockingly alien. A world that may hold the answer to one of the most profound questions we can ask: are we alone? Let's begin with the most fundamental ingredient for life as we know it: water. Here on Earth, where there's water, there's life. And the more we study Mars, the more we find evidence that it wasn't always the arid, dusty world we see today. In 2015, NASA announced the detection of hydrated salts on Martian slopes. These salts, called perchlorates, lower the freezing point of water, allowing it to exist in liquid form even in the frigid Martian environment. Satellite imagery has revealed clues of a vast, ancient ocean that may have once covered a third of the Martian surface. Deep, winding canyons carved by flowing water scar the Martian landscape. Scientists believe that vast reservoirs of liquid water may exist beneath the Martian surface, shielded from the harsh radiation and thin atmosphere above. If we find it, it could be a game changer, not only for the search for life, but for the future of human exploration on Mars. The possibility of liquid water on Mars transforms our understanding of the planet, from a desolate wasteland to a world with the potential to harbor life. As we explore the Martian atmosphere, we encounter another intriguing piece of the puzzle: methane. On Earth, 90% of atmospheric methane is produced by living organisms. So, when our robotic explorers detected plumes of methane gas erupting from the Martian surface, the scientific community went wild. Could these methane spikes be signs of microbial life, exhaling beneath the Martian soil? The mystery deepens. These methane bursts are sporadic, varying with the seasons and even disappearing entirely at times. Some scientists theorize that the methane could be trapped in ice, released during warmer periods. Others suggest geological processes, like the interaction of certain rocks with water, could be the culprit. The Curiosity rover is equipped with instruments to analyze the composition of these methane plumes. By studying the ratio of different isotopes within the methane, we can gain clues about its origins. Imagine yourself standing on the surface of Mars billions of years ago. The air is thicker, the skies are blue, and a gentle breeze ripples the surface of a vast freshwater lake. Across the Martian plains we find the remnants of ancient riverbeds, some stretching for thousands of miles. These winding channels carved by the relentless flow of water tell a tale of a time when rivers, lakes, and perhaps even oceans graced the Martian surface. By studying the composition of these sediments, we can piece together the history of water on Mars, its chemistry, its flow patterns, and its potential to support life. One striking example is the Jezero crater, the landing site of the Perseverance rover. These ancient riverbeds are like time capsules, offering us a window into Mars' warmer, wetter past. Here on Earth, we're accustomed to the ground shifting beneath our feet. But what about Mars? Is it a geologically dead world? Or does it harbor hidden forces deep within? In 2018, NASA's InSight lander touched down on the Martian surface, carrying with it a sensitive seismometer. Its mission to listen for Marsquakes, the Martian equivalent of earthquakes. InSight has detected hundreds of Marsquakes, revealing that Mars is far from geologically dead. These quakes offer valuable insights into the planet's internal structure. By studying how seismic waves travel through the Martian interior, scientists can map out the different layers of the planet. The data from InSight has already challenged some of our assumptions about Mars. A geologically active planet can generate heat, which is essential for liquid water to exist beneath the surface. For centuries we've gazed at Mars, wondering if we're alone in the vastness of space. Today that question is no longer a philosophical musing, but a scientific pursuit. The search for life on Mars is about seeking out the smallest, simplest forms of life: microbes. These microscopic organisms, if they exist, would likely be hidden beneath the surface, shielded from the harsh radiation and thin atmosphere above. Our robotic emissaries, the rovers Curiosity and Perseverance, are equipped with sophisticated instruments to search for signs of past or present life. One of the most promising areas for finding Martian life is the ancient lakebed of Jezero Crater. Perseverance is busy collecting samples from this region, samples that will eventually be returned to Earth for detailed analysis. The search for life on Mars is a painstakingly slow and meticulous process, but the payoff, if we find it, would be monumental. Here on Earth, we take our seasons for granted, but did you know that Mars experiences seasons too? Just like Earth, Mars has a tilted axis, which means that different parts of the planet receive varying amounts of sunlight throughout the year. However, there are some key differences between seasons on Earth and Mars. A Martian year is almost twice as long as an Earth year, lasting 687 Earth days. This means that each season on Mars is about twice as long as its corresponding season on Earth. Due to Mars's thin atmosphere and greater distance from the Sun, its seasons are much more extreme. Summers can be surprisingly warm, but winters are brutally cold. These extreme temperature swings have a dramatic impact on the Martian landscape. Take a deep breath. Our atmosphere, a delicate shroud of gases, is essential for life as we know it. But what about Mars? What's it like to breathe on the red planet? The Martian atmosphere is about 100 times thinner than Earth's, and it's composed primarily of carbon dioxide. This thin, carbon dioxide-rich atmosphere has profound implications for life on Mars. Without a substantial atmosphere to trap heat, temperatures on Mars fluctuate wildly. The thin atmosphere also offers little protection from harmful radiation from the Sun. Scientists believe that Mars once had a much thicker atmosphere, perhaps even one similar to Earth's early atmosphere. Understanding the evolution of the Martian atmosphere is crucial for piecing together the planet's history and its potential to support life. For decades, science fiction has tantalized us with visions of humans living on Mars. But what are the real prospects for human colonization of the red planet? Colonizing Mars is a daunting task, fraught with challenges. The journey itself would be long and perilous, exposing astronauts to cosmic radiation and the psychological stresses of prolonged spaceflight. Once on Mars, colonists would face a harsh and unforgiving environment, with limited resources and no room for error. Advances in rocketry, life support systems, and 3D printing are making it increasingly feasible to send humans to Mars and establish a permanent presence. Imagine a future where humans are no longer confined to Earth, where we have a backup plan in case of a catastrophic event on our home planet. Mars, with its vast resources and potential for terraforming, could one day become a second home for humanity. In the search for life beyond Earth, few discoveries are as tantalizing as the detection of organic molecules. These molecules, containing carbon-hydrogen bonds, are the building blocks of life as we know it. So, when our robotic explorers found evidence of organic molecules on Mars, the scientific community was abuzz with excitement. The Curiosity rover made the first groundbreaking discovery in 2014, detecting organic molecules in rocks from the Gale crater. These molecules, including chlorobenzene and dichloroethane, were found in sedimentary rocks that likely formed in a lake billions of years ago. The challenge now is to determine the origin of these Martian organics. Did they form through biological processes, hinting at the possibility of past life on Mars? Or are they the result of abiotic processes, telling a story of Martian chemistry rather than Martian biology? Here on Earth, we're accustomed to a 24-hour day. But what about Mars? How long is a day on the red planet? A day on Mars, called a sol, is slightly longer than an Earth day, lasting 24.6 hours. This difference in day length may seem small, but it would have a significant impact on any future human explorers or colonists on Mars. Our bodies are finely tuned to Earth's 24-hour day-night cycle, and even slight deviations can disrupt our sleep patterns, hormone levels, and overall health. The Martian sky also offers a unique spectacle. During the day, the sky is a pale butterscotch yellow, due to the scattering of sunlight by dust particles in the thin atmosphere. As the sun sets, the sky transitions to a pale pink, before fading to a deep violet blue at night. So, a day on Mars would be a unique and awe-inspiring experience, filled with longer days, a colorful sky, and the dance of two moons. Thanks for watching. If you enjoyed these weird facts about life on Mars, don't forget to like, subscribe, and hit the bell icon for more fascinating content from Facts with AI. See you next time. As we've journeyed across the rusty plains and peered into the ancient canyons of Mars, one thing has become abundantly clear: the red planet holds more secrets than we ever imagined. From the tantalizing hints of liquid water to the puzzling bursts of methane, Mars continues to beckon us with the promise of discovery. The quest to understand Mars is a journey we've only just begun. With each passing year, our robotic explorers send back more data, revealing a world both familiar and alien, a world that may have once harbored life and perhaps, just perhaps, still does. Until next time, keep your curiosity burning bright and never stop exploring the wonders of the cosmos.